Hello dear students, welcome back to a new video. I'm Mr. Mohammed from King's High School. In today's video, I'm gonna explain for you dilation. So as you can see on front of you on the screen, what's dilation? Let's understand. Is a transformation that changes the size of the shape but keep its overall the shape the same. Like we don't change the shape. When it's a square, we keep it square. When it's a rectangle, we keep the rectangle. But the only thing is what we do is resizing. For example, from the square, we can make it bigger or smaller. This is about dilation. Like not only bigger, we can make it smaller also. We have some important notes that you need to know about dilation. But before the notes, we have something calling scale factor. The angles stay the same as we can see it, and the sides stay the same in proportion using scale factor. What's scale factor? It's a value we call k, and if this value k was greater than 1, then this is calling enlarging. We enlarge the shape. But when k is less than 1, this is calling reducing. Gotcha? Okay, there are some important notes you need to know about dilation. First of all, dear students, dilation does not change the shape. As I told you in the beginning, we don't change the shape, only the size, only we're resizing. All angles stay the same. The figure remains similar to the original, like I did the square for you. The side's length change proportionally based on the scale factor that I explained also. Okay, students, so how we can do the process? First, to delete the shape or to resize the shape, you need to multiply the coordinate of the shape x and y by the scale factor, by the given scale factor. Okay, let's apply this one on an example. We have first example. In this photo that you see, the question asking to let's pick this color, to draw the border of the photo after dilation with a scale factor 3/2. First of all, students, before solving the question, the scale factor is very important, which is how much? 3/2. And we all know 3/2 is greater than 1, right? So we assuming that the graph going to be enlarging before solving. Okay, how many points that you see on this graph? You see point A, point B, point C, and point D. Each of them have a coordinate. For example, point A is located on 0, 0. Point D is on the x-axis. This is x-axis, by the way. This is y-axis. Located on the 1, 3, 3, 0. How about point C, located on 3, 4? This is 4, right? And this one, 0, 4. Okay. What you need to do to delete this photo, you need to, one by one, first point is A. You need to multiply, students, both x and y by the given scale factors 3/2, 1.5. So we will multiply, this is by the way x, and this is y, the order per right. We will multiply this one by 3/2 and y also by 3/2. So we get a prime, which is new point of dilation. When you multiply, you get 0, 0 back. Nothing changed, right? How about if I have point B? For point B, we have 0, 4. Again, you need to multiply both coordinates by 3/2. So 0 times 3/2, also 4 times by 3/2. So we get B prime or B dash, which is 3 times 0 is equal to 0, and 4 times 3/2, which we get 6. and you will keep this one for point C and point D also. So let's see the answers. Let's write point C. Again, you have 3 and 4. When you multiply by 3 over 2, you will do same process by 3 over 2, and this one also. So you get the answer C prime, which we get 3 times 3 over 2 equals 4.5, and 4 times 3 over 2, which we get 6, right? And for last one, which is point D, we have 3 and 0. Again, you need to multiply both x and y by 3 over 2. So D dash going to be 3 times 3 over 2, which is equal to 4.5 and 0. All right, students. And let's change the color to purple maybe. New point, A dash going to be 0, 0. So A going to be in its place same. This is A dash. How about B dash is 0, 6. So 0 on the x-axis, this is we say the x, and 6 on the y-axis. So going to be, this is 5, and this is going to be 6. This is going to be our new point about B. C dash going to be 4.5 and 6. 4.5 about x-axis, this is until here is 5. So between, this is 4, between them is 4.5. How about the other point, which is 6? So we can go all around here, so maybe somewhere in this point. This is calling C dash. Last point, which is point D, will be 4.5 and 0. This is going to be D dash. So you need to join these 4 points, students. So we get this point, and here also about this point. So here we go. This is our new shape. We just enlarge it by the scale factor 3 over 2. Okay, students, let's jump. Students, let's jump to the second example. In this example that you can see on the board, that given AOB, triangle AOB, and triangle COD, similar. This is calling similar. Find the coordinate of D and also the scale factor. So asking two things, the coordinate of D and the scale factor. Dear students, we have two triangles. The small triangle, which I will show you right now by color. This is the small triangle, the green one. This is the small triangle. And the big triangle is showed by orange. The big triangle, students, do you see this is the big triangle? All here, right? This is triangle. Let me rewrite. Small triangle is about O, A, and B. Also, the big triangle is about D, O, and this is C, right? The big triangle. Students, in order to find the coordinate of D, you need to use the ratio of sides, corresponding sides. And how to do that? Pay attention. The given coordinates that we have for B, for O is about 0, 0, and for point A 0, 2, for point C 0, 4. You need to use distance formula in order to find the length. For example, if I want to find the coordinate of D, I need to use the corresponding sides or similar angle method to find. How? I can say OA, this small part, over CO or OC, the corresponding sides over each other, the small over big one. AO over CO or OC. It should be the same as OB, this part, over OD. OB over OD, right? Also, it should be the same as AB, this part, AB over CD. But we don't want the third part because it doesn't give coordinate, and we don't want to give a headache to ourselves. All we need to do is finding AO, CO, OB, OD. OD, which is required because we don't know the coordinate from point A to point D. How much the distance? We don't know. This is our point. We can say this one is X. Okay. AO, the rest we can find them by using either distance formula, which I will explain, or directly you can say, since it started from 0, 0, directly you can say how many units far from the origin, the distance is that unit. For example, AO from O to A, how many units far vertically? Only 2 units far, because 3 of them 0, only 2 units far. So we can write 2 directly, or you can use distance formula. From O to C, only 4 units far, so we can write 4. This is the same as OB from point O to B is 3 units far, so we can say 3. And from point D, we don't know, so we write X. So cross multiply in order to find X. We get 2X equals 12 divided by 2 both sides, so X equal to 6. We found that from O to D the distance is only 6 units, and we can write the coordinate. Let's erase this part, please. The coordinate of point D, it's 6, 0. Maybe someone asking, teacher, why not 0, 6? Because this is on the x-axis, and on the x-axis y 0, and this is the value of X. How about the scale factor? The scale factor, which is K, which is second, let's say, required from the question. K equals how much? K equals the big part, the big, let's say, unit, big side over the small one. For example, OD over OB or OC over OA. Both of them, you will get the answer. Big triangle over small triangle side. So I can say either 6 over 3, which is OD over OB, or I can say OC over OA. So 6 over 3, K equals 2. This is going to be final answer. All right. We have a try. This is similar to this question I just solved. I can solve this one for you also. We have, let's say, point P, which is negative 15 and 0. Point M also given. Point Q given. As you can see, point Q given. Coordinate. But point N is required. We don't know, right? From these two triangles, MON and POQ. Let's redraw them. Small, little bit to you understand. So this is first triangle, which is based on O, M, and N. The small part. The big triangle is based on what? Let's write. The big triangle is about O, P, and we can say Q. Okay, students, again we can use distance formula. Here we have from point O to M, how many units far is 10 units. We cannot write negative 10 for distance. That's why I'm okay to write 10. Or you can use the distance formula. Distance formula is about between 2 points. We can say x2 minus x1 square plus y2 minus y1 square. This is the distance formula to find distance between 2 points. So, or directly you can say 10. How about from point O to point P? OP, the big part. From O to P is negative 15. That's why we can say directly 15 without negative, okay? All right. How about from O to Q? It's negative 30, so we can write directly 30. How about from O to N, which is our value? We can say Y or X or any unknown variable that you can use. So the corresponding sides over each other, we can say 10 over 15 MOM over OP should be the same as ON, which we are looking for, over OQ. Okay, students, OM in this question is 10. How about OP is 15? It's the same as ON, let's say Y, OQ is 30. You can do cross multiplication or simplify 10 and 15 together. No difference. So 15y equals 10 times 30 equals 300. Divide by 15 both sides. Y equals 20. Right? So but I cannot write 20 for this coordinate. Who knows why? Pause the video if you don't know. Think about it. I cannot write, by the way, this is y-axis. This line, this vertical line is y-axis. And this one is below x-axis, so I cannot write down 0, 20. But I must write 0, negative 20. Because the coordinate of n is in the down of x-axis. Alright, that's why y there is negative. About scale factor k equals how much? K equals the big part 30 or 15 over 10 or 30 over, let's say, 20. We can say 30 over 20. 15 over 10 also you get same answer. So K equals 3 over 2. This is the scale factor used to enlarge these two triangles from OMN to OPQ. Dear students, we have example 3, but before, as you can see here, I explained for you the distance formula. When you want to find the distance between two specific points, like these 2 points that you see on the board or on the screen, point A and point B, x1, y1, x2, y2. So you need to subtract the x's together, x2 minus x1 square and y2 minus y1 squared, and the square root, you will get a distance. To prove these two triangles, we have different ways, so we will use the distance formula. Okay. So in this question, we have 2 triangles again, ABC, this small triangle, and also ADE, second triangle. The question saying prove they are similar. We already know they are similar, but we need to prove them. How to prove they are similar, students? You need to, again, prove the corresponding sides. Let me redraw the triangles. The corresponding sides over each other must be similar. A, B, C, and the big part which we have A, D, E. Okay, you need to find AB, the small part, this part over this part, AB, BC, AC, sorry, over AE. Okay, or BC over DE, no different. Students, you need to find out, or you need to prove AB over corresponding side is AD. This one should be the same as AC over AE. You need to find all 4 in order to prove. So let's work out all 4 right now here in this part of the paper. So from point A to point B. This is point A, this is point B. x1, y1, x2, y2. So you will subtract by using distance formula. x2 minus x1, x2 here is negative 1. So we will say negative 1 minus 1 squared. Plus y2 minus y1, 3 minus 5 squared. Okay, let's go to the other parts, then we will calculate all together. Second one, students, we have AD. AD equals how much? From A to D, this is point D. Again, A let's be x1, y1, D let's be x2, y2. So negative 3 minus 1. Negative 3 minus 1 squared plus 1 minus 5 squared. 1 minus 5 squared. So let's get the answer. Let's go to the second part, AC. So AC equals how much, students? AC equals, really quick, point C. Again, let's make this one x2, y2. 3 minus 1 squared. 3 minus 1 squared plus 4 minus 5 squared. We get the answer. And last one, which is AE, we have, again, let's make this one x2, y2, and point A let be still x1, y1. So it will be 5 minus 1, 5 minus 1 squared plus 3 minus 5 squared. So the first one, negative 1 minus 1 squared equals negative 2 square 4, plus this one 4, so it will be square root of 8. This part going to be, this is 16, this one also 16, so square root of 32. This one going to be 4 with 1 square root of 5, and if you calculate this one going to be square root of 20. So let's substitute all together to calculate. Okay, dear students, AB is about square root of 8 over AD is square root of 32. This is the same as square root of 5, which is AC, over square root of 20. We all know, let me write down here for you, square root of 32, it's about square root of 8 times square root of 4, which equals square root of 32 back, right? When you simplify this one also, it's about square root of 4 times square root of 5. True? So let's rewrite them as in this form. So square root of 8 over square root of 8 times square root of 4 is the same as square root of 5 over square root of 5 times square root of 4, which is square root of 20, or radical 20. Then, students, we can cancel the same radicals because it's multiplication, and 5 also. We get 1 over square root of 4, we get 1 over 2, so final answer going to be 1 over 2 is the same as 1 over 2, and we get the same ratios in both sides, so this is going to be the answer. Thank you for watching until now, and I hope you understood the point of dilation and let's say the topic in general. For any question, anything else, you can write for me in the description or in the comment below. Stay tuned until next video. So see you. Have a nice time. Bye bye.